Hello everyone, my name is Rohan. Me and my colleague Ashish Agarwal are going to present to you on the topic of advanced statistical databases. Some of the main objectives which we like to achieve from this presentation is to give a bird's view about statistical databases, its uses, its importance, and some of its issues. Before we start talking about statistical databases, we need to understand the different types of statistical data. Statistical data mainly consists of three types: microdata, macrodata, and metadata. Microdata is data about individual objects, such as units of population, individuals, households, or establishments. They are collected by a census, survey, or an experiment. Macrodata, on the other hand, is summarized data or collection of objects, estimated values of statistical characteristics, or basically statistics. Metadata is data about data. It can be broken down into three types: exploratory metadata, explanatory metadata, and technical metadata. So what exactly is a statistical database? A statistical database is a collection of statistical data. It is stored in an organized way so that it serves the purpose of managing statistical data, especially macro data and its associated metadata. Statistical database management systems may be built on top of relational database management systems, or they can be created from scratch. A statistical database is a database that provides statistics on subsets of records. They are OLAP, which is online analytical processing, instead of OLTP, which is online transactional processing. So you might wonder, why do we use OLAP and not OLTP? In OLTP database, there is detailed and current individual data, which is of very high volume and less complex, whereas OLAP is characterized by relatively low volume of transactions, but queries are often very complex and involve aggregation. As a result, statistical databases allow query access only to aggregated data and not individual records. Currently, statistical databases are implemented across a wide variety of domains. Some of the common examples are health statistics, labor market statistics, housing and construction, transportation, business, energy, and trade. In the coming slide, we will showcase one example of how statistical database is used in these domains. In health statistics, care, producer, patient, and disease act as basic object types. Complex object types include events or activities such as care producer activity or patient activity. A care producer activity may involve one or more care producers and thus many-to-one relationship. All objects are described by the means of variables. Some variables are classification variables, such as the name of the care producer or the name of the disease, and others are summation variables, such as income earned through producer activity. The next question that comes to our mind is, why do we need statistical metadata when we can have individual data and statistics can be derived from individual data? Firstly, in order to analyze data, users of statistics need good metadata. It is important not to expose individual data to these statistic researchers. Similarly, operators and producers of statistical systems need metadata in order to execute and monitor the production process properly and for training new staff members. Also, producers and planners of statistical systems need metadata for designing, construction, and implementing statistical systems. Statistical databases can be bifurcated as static and dynamic databases. In static database, once the data is entered, it cannot be changed again, whereas in dynamic database, there is a continuous change to reflect the real-time data. The common example of a static database is the US Census information, whereas most of the online research databases include information which is currently changing. There are four main stages during the life cycle of a statistical data and metadata. Raw data from the database is extracted and then passed to a statistical database to filter out end product of statistical data. These stages may vary depending on the intermediate process and how individual data is prevented to reach out to the final destination. In the following slides, we are going to discuss some of the methods to aggregate data. Data can be aggregated by only allowing aggregate queries like sum, count, average. Another method is, rather than returning exact values for sensitive data like income, only return which partition it belongs to, say 35K to 40K. Another way is to return imprecise counts. For example, rather than 141 records met query, we can only indicate that there were between 130 to 150 records that it met. There are some more examples to it. Data aggregation methods can be broadly classified into 3 or 4 categories: query restriction, data or output perturbation, and microaggregation. We will provide a broad idea about these one by one. An example of query restriction or query set control is where a query set size control limits the number of records that must be in the result set. This feature is used by Amazon Search while searching for products. Amazon has restricted its output search limit to 20,000 even when there are millions of products available online. As you can see, K is the size restriction. Only on the left hand side you can see that query 1 results are less than the restricted size, hence the data is available, whereas in other case, results exceed the size limit and hence the data is not visible. Next comes data perturbation. Perturbation refers to causing disruption. In order to disallow confidential records from accessing directly, output data is often disturbed by added noise. A perturbed database is created by adding noise to the original database records, and users are allowed to query on this distorted database instead of the original database. Output perturbation is another form of data perturbation where there is no additional perturbed database, but instead the output results are perturbed by adding noise. Thus, this technique is cost effective when compared to data perturbation. Another technique which is used to aggregate data is microaggregation. In microaggregation, records are grouped based on proximity measures of variables of interest, and the same small group of records are used to calculate aggregate for those variables. The aggregates are released instead of the individual record values. While for the proximity measure, different concepts can be used, the aggregation itself is naturally done with the arithmetic mean. Nevertheless, other measures of location can be used for aggregation, especially when the group size for aggregation has been taken higher than 3. Since the median seems to be unsuitable for microaggregation because of being highly robust, other measures which are included can be chosen. If a complex sample survey is microaggregated, the corresponding sample weight should be determined to either aggregate the value by the weighted arithmetic mean or the weighted mean. This helps to prevent disclosure of individual data. An example of an organization which uses this technique is the National Agricultural Statistics Service (NASS) that publishes data about farms. As discussed earlier, this is a small representation of microaggregation of data. Records are clubbed into smaller chunks and output data may be represented as arithmetic mean or weighted mean. In this case, the data is represented by the average or arithmetic mean. So you would be wondering which one of the previous mentioned techniques are the best for data aggregation. On a broader base, we can say that query restriction techniques cannot avoid inference, but they accurately respond to valid queries. There is no noise added to the output, but the number of responses are restricted. Data perturbation techniques can prevent inference, but they cannot be easily consistent to provide useful query results as data is corrupted by random noise. Output perturbation has low storage and computational overhead, however, is subject to inference and inaccurate results. There are some live companies which make extensive use of statistical databases. Companies use statistical database for rate making, reinsurance pricing, classification analysis, benchmarking, strategic planning, underwriting, and marketing. Several companies like SAS and Statista use statistical database. Several libraries which want to restrict individual records to outside sources use statistical databases. International trade companies also use statistical databases. Government offices also use statistical database for various purposes such as population statistics demonstrated before. Finally, we want to conclude that although statistical database allow restrictions on output query data, they are not foolproof, as there are several methods to get individual data from statistical data. According to Dorothy, restrictions on allowable query set sizes will render the database useless as a source of statistical information, but will not secure the confidential records. There is a lot more to be done in this field, and more research is being done in universities and laboratories. Since large amount of data is involved in several applications, this area possesses interesting, challenging, and real problems that should be addressed by database researchers.